Hi everybody, welcome to another video in Trigonometry, section 4.3. Now we'll learn more about graphs of trigonometric function. On the previous section, we learned about two things, amplitude and the period. So the amplitude will tell us the bound. Usually only sine and cosine function have amplitude. So the graph of sine and cosine will bound between those two lines. The period, all circular function have period. So the period will tell us what happened on one windows, and then we just copy and paste that throughout the whole number line. And the amplitude will be determined by the number in front of the function. The period is determined by the number in front of the x, the very independent variable. So normally, if the period is 2 pi, then with b, there will be 2 pi divided by b. If there's tangent, cotangent, will be pi over b. So normally, if there's sine, cosine, secant, or cosecant, any function that the period is 2 pi, where we multiply by a number in front of the x, we divide that number from 2 pi. If the regular period is a pi, we divide pi by that number in front of x. So that is the amplitude and the period. We'll do that again in this section. But this section we add a few more things. Phase shift. The phase shift is where the trigonometric function, where we should start a period, where we start windows. Of course, the period, when we have the graph, a period can be anywhere, can go from here to here, as long as the graph repeats itself. So if we have the graph like this, we can copy and paste and we generate the whole graph. So the period doesn't have to, the period can start at any point. But in terms of graph, it will be easier if we determine the phase shift. The phase shift is when we graph, this is where we start with a period. So that will help if we know the phase shift. So once again, if this is the graph, the number in front of the function, this will give us the amplitude. And this number will give us the period. So if it is 2 pi for the regular function, we divide by b, 2 pi divided by b. If regularly the period is a pi, we're going to divide by b also. Now the phase shift. This is how we determine the phase shift. Actually, it will be a lot easier just to do this. So to find the phase shift, we just let this equal to 0 and whatever shown for x, and that is the phase shift. So phase shift bx minus c equal to 0. So x is equal to c over b, and that is the phase shift. A phase shift is conveniently where a period starts at the phase shift. If it's positive, it's on the right of the x-axis. If it's negative, it's start on the left. Let's put all of this together and try to find the graph of this example. So y equal to sine of x minus pi over 4. So first, the amplitude. There's nothing in front of the sine x, so the amplitude is absolute value of 1 or be just 1. The period. Yeah. So here we just have 1 in front of it. I will write this function again, y equal to sine x minus pi over 4. Amplitude is 1. There's 1 in front of x, and the period is regularly sine cosine. The period is 2 pi divided by that number in front of x, so it's still 2 pi. Now, what's new here is the phase shift, where period start. So phase shift, we're going to let this equal to 0. So x equal to pi over 4. That's where I start. Right. And then the pattern for sine is going to be middle, max, middle, mean, and back to middle. Right. So the amplitude, that probably the easiest one. First is going to be 1. So 1 up, 1 down. Right. Now the difficult thing here is we cannot just choose randomly 2 pi is something, right? That would be a problem because there are two numbers, 2 pi and pi over 8. So in relation, what is 2 pi and a pi related? We have to do consider the scale here. So let's do the sketch work here. What is the 2 pi and then pi over 4? So if you take 2 pi divide by the phase shift, let's see the scale. So 2 pi multiply reciprocal 4 over pi. That cancels, so it's 8. So the period is 4 times the phase shift. So the period is 4 times as long as the phase shift. So if you choose the phase shift to be this much, then the period is going to be 8 times that long. So it's not reasonable. So that's why we have to do this calculation to get the scale. So we choose the reasonable scale. If we choose the phase shift to be here, it's to be pi over 4. Then the period is going to be 8 times that long. So that looks reasonable. So this little is a phase shift. Multiply that by 8. So 1, 2, 3, 4, 5, 6, 7, and 8. So this will give us 1 period. In particular though, if we start from pi over 4 and we add a period, so we just do this 1 over 4 plus 2, and that is 9 over 4 pi, 9 pi over 4. Right. So we have to find a relation between an amplitude, the phase shift and the period to choose the scale to be correct. Of course, we cut this in half and in 4 equal pieces. The pattern: middle, max, middle, mean, back to the middle. Of course, if we want to, we can say half of that is the period is 2 pi. So the halfway point is a pi. So we add a pi to 5 pi over 4. So here we can get like 5 pi over 4. We can get actually all those points here if we want to, right? So the midpoint is a pi. Pi plus 5 pi over 4 is 5 pi over 4. So this is 5 pi over 4. But the graph though is going to be this. So for one period, copy and paste throughout the whole number line. That part is easy. So 1, 2, 3, 4, 5, 6, 7, 8. That's another period here. Middle, maximum, middle. Sorry, this will be middle, minimum, and then back to middle. Right, so like that. So we know the phase shift where the graph start, and we have to compare that with the period to see to choose a reasonable number for that. Right, we'll do a few more samples of this, don't worry. So amplitude for this problem. So amplitude, there's a 2 here. So absolute values of that. Here was the amplitude. The period normally for sine cosine is 2 pi. Divide by that number. So just a pi now. Phase shift. We're going to let this equal to 0. So for that, x equal to negative pi over 2. 2x equal to pi, negative pi. So x equal to negative pi over 2. So that's where I start. Once again, we have to choose the phase shift, choose the scale for the phase shift and the period so it looks reasonable. If we choose the phase shift to be too small, the graph will be too small. If we choose the phase shift to be too small, the period too small, we don't really see the graph. So we have to be reasonable here. So amplitude, that's different story. In fact, that doesn't affect our problem at all. So we can always just draw the amplitude here. It's 2, so 2 up and 2 down. Phase shift. So the period is a pi of phase shift. The length of that we can just ignore the minus here. Just take the pi divided by pi over 2. So let's see in relation between the period and the phase shift. What do we have? By the way, it could get a fraction, but at least we have to choose the scale so it look reasonable. Multiply reciprocal, so it's going to be 2. So meaning that the length of the period is going to be twice the length from 0 to the phase shift. So if you choose the phase shift, this is negative. If you choose this to be here, the period will be twice as long. If you choose it to be here, the period will be twice as long. So choose something reasonable. Because a period is usually divided by 4 equal pieces. So I choose something like here. So I have 4 equal pieces for one period. Right. So negative pi over 2 is that much. So phase shift is that much. The period will be twice as long. Will be twice as long from 0 to the phase shift. So if we want to, we say the phase shift is negative. Just ignore the pi, so negative 1/2, and then add a pi. Again, ignore the pi. So that will give us 1/2 pi. Yeah. Usually when we do the calculation with the pi to it, just take the pi out, do the number first, negative 1/2 plus 1. At the end, we stick the pi to it. So that gives us 1 period. And then the pattern, this is sine again, so pattern. It's going to be that. So middle, max, middle, mean, back to the middle. That is the graph of one period. Now we just copy and paste this throughout the whole number line. 1, 2, 3, 4, 5, 6, 7, 8. That's the same. Yeah, so it's like that. So we need to find in terms of graph to make it look correct and look reasonable too. If we choose the period to be, the phase shift to be too small, the period will be small, because we have to know the relation between the phase shift and the period. Because both of them are on the x-axis, we have to choose the scale properly. Because if we want to graph y equal to, by the way, make sure that it is in the right mode, which is radian. Now we want to graph 2 sine 2x plus pi right. Let's change the scale. Look like let's say it only go from -2 and 2, so we don't need that much windows, hit windows. Let's go from -pi to pi, -pi to pi, and the increment, let's say pi divided by 4, right? Y, let's go from -3 to 3 only. Right? And you see the graph go to 0, and here is -pi, so that half of that, so -pi over 2 to pi over 2, so that's what we have. Of course, that looked like the graph of negative sign, but again, we can certainly, if the period starts from here, it looks like negative sign, but again, that's not the problem. So this, we don't have negative, so this pattern, again, middle, max, middle, mean, back to the middle. Right. Next, I'll find the phase shift of this. Of course, the phase shift, I will just let that equal to 0. The argument or the angle, I could multiply everything by 2 to get rid of the denominator. So 3 pi, multiply everything by 2, that gives us 6 pi. X plus pi equal to 0. Move the pi to the other side. 6 pi x equal to -pi. And divide by 6 pi on both sides. X equal to -pi over 6 pi. So -1/6. Right. We just need to find the phase shift for that one. Now we're going to graph. What if we have to graph secant or cosecant? So when we graph a secant or cosecant, we're going to graph the reciprocal function. So consider what we're going to consider is y equal to reciprocal of cosecant is sine. I just write the angle again. Right. So now I just only consider this one. Ignore that. Yeah. Ignore that function. Okay. Now, for this, I would write the same thing: amplitude, period, and the phase shift. And we graph this function first, and then we go back to the cosecant later. So amplitude for this function is 1. Period. Normally sine cosine the period is 2 pi, but we have to divide by the coefficient of x. Multiply reciprocal. And then phase shift. We'll let this equal to 0. Right, move the pi over 4. If we're trying to get rid of the fraction, we should do that. Multiply both sides by 4. 4 times 1/2 is 2x. Plus pi equal to 0. And then we solve for x, move the pi over to x equal to negative pi. So x is equal to negative pi over 2. So that's where we start the phase shift. And also the pattern for sine. Oh, this is okay. It would be nice if, because the first two examples are sine, but it's still fine. And we have the graph for cosine later. Right, pattern of sine, that function. Middle, max, middle, mean, back to the middle. Right. The amplitude doesn't affect by the period and phase shift is 1. By the way, the characteristic of the secant and cosecant is that they bouncing up the maximum and the minimum. So if you choose the amplitude to be way up here, the graph will be way outside of that. So I choose kind of reasonably small because the graph will bounce off it anyway. Amplitude, 1 up, 1 down. The period and the phase shift. So we have 4 pi and negative pi over 2. Once again, we have to divide them to see in relation what are the scale is going to work. So the period is 4 pi divided by just the pi over 2. Again, if you want to use a calculator, just take the pi away. So 4 and 1/2, pretty much. 4 divided by 1/2. Is 8. So whatever we choose for the phase shift from 0, this is to the negative sign, the period is going to be 8 times that long. So if we choose the phase shift to be start here, 8 times as long will be way over there. So that's way over there, it doesn't work. So we have to choose relatively small, about this much. So I have to choose that. So reasonably small. And then we choose 8 times that will be a period. 1, 2, 3, 4, 5, 6, 7, and 8. So that gives us 1 period. One, 2, 3, 4, 5, 6, 7, and 8. So that gives another period. So the pattern, middle, max, middle, mean, back to the middle. And then you say, what is actually this point is? Well, we can say it, we start from the phase shift, negative 1/2, plus a period of 4 pi. So that gives us 7.5 pi, 7 pi over 2. be this point. And you say, how about this point? Well, if the period is that much, that will be half a period, which is half of 4 pi, which is 2. And so we start from the phase shift plus 2 pi. That is 3 pi over 2. Yeah. And then this is the quarter away from the phase shift, so we just find the quarter of the period and then just add to it. So we can actually find all the points here if we need to. And of course from here on the left, so we subtract 1 period. Start from the phase shift. The period is 4 pi, so we subtract a period from it. We have negative 9 pi over 2 be here. And the graph of sine dependent graph at that. Now finally, we're not graphing sine, we're graphing cosecant, right? So cosecant, first of all, where it is equal to 0, that will give us the asymptotes. So asymptote will be where the reciprocal function equal to 0. That gives us the asymptote. Where the function equal to 0, there will be the asymptotes. And then the rest will be easy. The graph of this, the reciprocal function, whenever it is 0, there's an asymptote, and then it just bounces out the maximum, the minimum, so this is the graph of y equal to cosecant 1/2 x plus pi over 4. If we want to graph it on the calculator, again, make sure it's in the radian mode. And then we're going to graph cosecant. We cannot really type that, so 1 divided by sine of, I just type 0.5 instead of 1/2 plus pi over 4. Of course, we need to change the scale. Look like from here, that is about a little 4 pi. So let's go from 4 pi to negative 4 pi. Negative 4 pi to 4 pi. And each increment is a pi. Y values good enough. So from negative 4 pi to 4 pi, so we should look at the graph is about in that windows. So the graph should reflect that. So look, correct. Right, the last thing in the transformation of the graph. So once again, the number in front of the function will tell us the amplitude, if there's any. The number in front of the x will give us the period. Whatever the period is, either 2 pi or pi, divided by that number. When we let the whole argument, the whole angle equal to 0, that gives us the phase shift where the graph starts. And finally, what we have is, if we add the number into the function at the end, that gives us the vertical shift where the graph starts vertically. Right. Now, how did that work? Let's just look at the function here. But when we did too many sine, let's change this to cosine. I would change this in the note that I post online. Don't worry. So we've done too many sine. How about just cosine on this one? Right, so same thing. Amplitude which is the number in front of the function, 2. Absolute values of that, still 2. Period. For sine, cosine, that's where we start with 2 pi. And the coefficient of x, the number in front of x, there's none or just 1. So here is a pi. The phase shift. By the way, this is 2 cosine of x minus 1. The 1 is not inside the cosine. The phase shift. Our phase shift is wherever we let the argument or the angle equal to 0. So just make, in this case, it's just x equal to 0. And the vertical shift, this one is new. So when we have the function, whatever the last number that added to the function, that gives us the vertical shift. Right now, so let's say vertical shift is -1. Or we can say y equal to -1. Okay. Now, so -1 is where the shift. So normally the graph is like this. So we will shift vertically up or down. So also like what we choose earlier between the period and the phase shift, we divide them to get the right scale. Here we have to choose the number that look reasonable between these two. If you say 2 is this much, then -1 is that much, so that look reasonable, right? So the key point is you don't want to choose too big of a number. That make this too big. Don't want to do that too small either. So if I choose -1 here for the vertical shift, I'm just going to draw the very light. So that is the vertical shift, -1. And then that's where we start first. That the first thing we graph is the vertical shift. And then we go to the amplitude. It's 2. We go 2 up, 2 down. So 2 up, 2 down. So the vertical shift is the first thing we do. And then go up and down the same thing, give us the amplitude. Phase shift, in this case that's easy, 0. And then the period is 2 pi. So in that case, we don't divide them, by the way. That divided by 0 is undefined. So what I mean is, if we're going to go 2 pi for the period, make sure that you can divide that into 4 equal pieces. So this is 2 pi for one period. 2, 4, -2 pi. That gives us a window for a period. So since we order them, so there will be 3 and then 4. So this is the graph of the order. Vertical shift first, amplitude, phase shift, period. That's what we graph. And then finally the pattern of cosine. Maximum, middle, minimum, middle, and then max. Maximum. The middle is not 0. I didn't say 0, right? I said it's the middle, which is the vertical shift, the middle line. Okay. Minimum, middle, then maximum. So that's the graph of one period. Copy and paste this throughout the whole number line. And that's what we have. So, yeah. So that means we have everything on it. Now, if we combine all of this, of course, they just graph. So for the transformation, there's the number in front of it give us the amplitude. The number in front of the x give us the period to divide from 2 pi if it is sine cosine, divide by pi if it is from tangent cotangent. The phase shift, let that equal to 0, and the vertical shift, whatever the last number added to the function. Right. Now once we have all of those and the pattern of the function, we pretty much can graph it. So here, amplitude, the amplitude, two, period, for sine cosine normally is 2 pi, but I have to divide by this. If I want to rewrite it, it should be 2 sine of 1 oh, it's going to be a little bit of work. I'm going to put the negative here. If I factor out the negative, we have 2x minus pi over 4. Right? Now if you multiply it out, negative 2x, negative, negative is positive. So that's why this should be negative. And finally, one thing we haven't used often, I mean, that chart. So, this is the sine function, right? So in the sine function is odd. What does it mean if the function is an odd function? So if the function is odd, since the function is odd, the negative will bring out sine of the function. So take the negative, bring on the outside. Because it's odd, function f of negative x is equal to negative f of x. So in that case, what we have to consider is y equal to negative 2. What we're going to graph is negative 2 sine of 2x minus pi over 4. This is the graph that we're going to graph, which is the same as this function. Right. Once again, the number in front of x should be positive, so that's why we factor the negative out. So we should have like the number in front of x, the coefficient of x is positive. Right, the amplitude doesn't change much, but in this case it's still 2 though, but we put absolute values of that number, so it looks right. The coefficient of x, 2 pi divided by the coefficient of x, which is 2, so the period is a pi of phase shift. Let that equal to 0. Multiply everything by 4. Multiply everything by 4, that gives us 8 x minus pi equal to 0, and then so for x equal to pi over 8. That is the phase shift. Right, move the pi over, divide by 8. Now from here we can see that the period is a pi, the phase shift is pi over 8, so the period is 8 times the phase shift. In this case, vertical shift is the number that add to it. I forgot. Plus 2, plus 2. So vertical shift is 2. Right. That exactly the first thing we do is 2. Now the vertical shift is 2 and the amplitude is 2. If you choose 2 to be too big, it will get out the screen of the windows here. So let's say if you choose 2 is about here, about that much. So that gives us the vertical shift dash dot dot and then dash. So I just round. So that is the phase shift. It's going to be the middle line. Amplitude is 2, 2 up, 2 down. Or 2 up from 2 is going to be 4. Or 2 down is going to be 0. So if I ask you what is the range for the problem, and then you can say the range in this case from 0 to 4. Because 2 up, 2 down from 2 is going to be from 2 to 4. I mean from 0 to 4. Right. Phase shift and period. Pi over 8, so this is 8 times, so you have to choose something reasonable. If it is pi over 8, the period will be 8 times that long. 1, 2, 3, 4, 5, 6, 7, 8. It was 1 period. Then 1, 2, 3, 4, 5, 6, 7, 8. Of course, if we want to get those numbers, we're going to start with the phase shift 1 over 8 plus a pi, which is just 1. Wait, sorry. 1 over 8 plus 1. Hit math, convert to fraction, 9 pi over 8. So in that case, we can get any point here if we want to. So that is 1 period, right? Now, the pattern of negative sign. Usually the sign is go from the middle to the max, but this is negative, so middle to the mean, back to the middle to the max, and then back to the middle. This is the pattern for the negative sign. Right, the graph. Middle, start from the phase shift and the middle line. Go to the mean, back to the middle, max to mean, back to the middle, I mean. Right, and copy and paste. Throughout the whole number line. Right, so that's what we have. Right, another example. This one. I'll find amplitude, period, phase shift, vertical shift, and then graph. Pretty much, this has everything on it, and we don't have to do much here, right? So, amplitude, that is 3, so absolute value of that is still 3. Period, normally is 2 pi for sine, cosine, but we divide by pi here, the coefficient of x, number in front of x, that gives us 2. Period is 2. Phase shift, the phase shift, we're going to let this equal to 0, pi x minus pi equal to 0, move the pi over and we solve for it. Pi x equal to pi, so x is equal to 1. And the period compared to that will be twice as long. Vertical shift, -1. And that's where we start with. So -1, amplitude is 3, so choose something reasonable. Yeah, if you choose that small. That is the phase shift of -1. Right, amplitude 3, so 3 up and 3 down. Yeah. So that's why we don't want to choose the -1 to be too big, because we need to multiply that by 3. So from that -1, go 3 up and 3 down. 1, 2, 3. So 3 up, -1 plus 3 is 2, -1 minus 3 is -4. Right, phase shift is start 1 and the period is 2. If you want to choose too small the number, the period will be just twice long. So that's why we have to find the scale between this and choose something that's reasonable. If we want to choose 1 here, the period will be twice long. Still not good. So how about we choose 1 is here on the x-axis. The period is going to be twice long. Let's see, 1, 2, 3, 4, so be twice long. So that gives us 1 period. Right. So we start at 1 and then go by 2, so that's obvious 3, and the middle is because it's 2. But that's just that. Now this is cosine, right? So the pattern of cosine. Max, middle, mean, middle, max. Max, middle, mean, middle, and max. So that's what we have. So quick recap, we start with the vertical shift. That's the first thing we do, and then the amplitude. That gives us the range for the problem. In this case, the range is from -4 to 2. And then the phase shift where start of the period, and then add the period to it. We have the windows. Graph that, and then copy and paste throughout the whole number line. So that's how we graph trigonometric function. So that's pretty much everything we can possibly have in the problem. Amplitude, period, phase shift, and vertical shift, and everything in one problem. Right, so I stop this section here, and actually that's the end of the chapter as well. As always, thank you for watching. See you in another video in trigonometry.